Hey guys, so today you and I are going to talk about complicated solutions without readable code. So let's get into it. So the question in question was, hi Frederick, have you come across scenarios where a complicated solution cannot have readable code? Well, yeah, I would say so. Because readable, like, it's subjective. What does that mean? It means different things to different people. So what I like to tell people is that if you're a software developer who comes to, say, a new project, and you have to deal with one of those highly advanced technical, like in the last video that I made, I talked about that, where you might have one of those situations where you don't think you're ever going to get there, but I promise you it does happen. It's happened to me more than once, where you actually need to know how to traverse a graph, how a recursive method function works, or how graph theory or something sophisticated like a sorting algorithm or something like that, where you actually need to know about these things because the problem that you are facing is that sort of problem. And the best part is when it's one of those problems where the people have implemented it, have an implementation in place without any tests, no type checks or anything like that, and you sort of have to basically just start adding logs, or if you're lucky, you can use a debugger, and sort of just traverse the thing until you figure out sort of what the intention behind the feature is. This is one of those times what I've also told you guys, where in some cases the code is so ugly that it's better for you to just figure out what the feature should be doing and then re-implement that specific function from scratch, because it might actually be buggy in the first place. You can't just add stuff to it. You actually need to know how this works so that you can fix it. And so I've been there a few times, and recently in my last little story I told you about it. Basically, I had this issue where we had this traversal problem, right? Where I needed to basically create a file from like a file explorer from scratch on a web application. And so the problem with that is that the complexity of I mean, I of course, when I was done with the implementation, I felt that this was understandable, it was readable, but the reality is that it took me, certainly, like if we think about the total amount of, like, if we include me figuring out all the features, because I don't know guys if you've thought about that, but the file explorer and like being able to right click and select different things, and then you have different states, open, close, like nesting things and so forth. There's a lot of functionality in a file explorer, and it's actually a fairly sophisticated data structure to get right, especially when you have all these extras that you might have to deal with. So it took me certainly 2 or 3 days total to get that into like a working state where I could actually say, yes, I can ship this thing, like, and it's going to stay stable, because I needed to add the test and like all that stuff that wasn't there, of course. And when I was done with it, I felt that I knew what was going on. But I then, of course, a little while later, come back to that code and realize that, damn, well, how was this thing? How did it work now again, right? So just because that's sort of the problem, right? If you have spent the time to understand a piece of software, and you spend enough time with it, even if it's the ugliest thing in the world, it's probably going to feel fairly straightforward, because that's the curse of knowledge, right? As soon as you know how it works, or you figure it out, then everything is easy. Well, in theory at the very least. And so making a solution, like, because this touches on something that I've talked to you guys before about, which is the difference between inherent complexity and circumstantial complexity. So when I took over this project, or when I took on figuring out this feature, there was a lot of circumstantial complexity, because the code wasn't very clean. There were no types, no tests, no nothing. Like, there was nothing to go on, and the overall solution was not that clean, because the people who had implemented weren't all that familiar with how to deal with, say, graph problems or so forth. So without getting any support, I sort of reversed engineered the feature based on the specification that was there, and then I basically started from scratch, implemented it in what I believe, of course, is a readable and more nice format. And so I remove, quote unquote, a lot of the circumstantial complexity. So I simplify the problem, and I can show it to other developers, and they say, yes, this is a more clean, it's a cleaner implementation of this thing, right? But for anybody who's ever done a leet code challenge or something like that, you will know that even if I created the simplest possible, most readable, maintainable solution, this is a sophisticated problem because of the inherent complexity of the problem. That's the issue. So basically, when I showed this code to a new coworker started a few months later, and I told them this is what this does, and he said, yeah, I'm going to have to take some time to read through this because I can't really understand what this code is doing. And I completely understood that, because of the same reason I understand that people have a hard time dealing with leet code exercises, because the problem domain itself is so complicated and the feature requirements are so complicated that it's very difficult to make this thing more readable than it is. It's sort of like, you know, reading a menu at McDonald's will always be easier than understanding that than understanding, say, a chapter of your law book or something like that, because the complexity of that language and the complexity of the domain is much higher, or finances or taxes, take whatever you want, right? The problems are vastly different in proportion, and so that's why I argue that in that scenario I can't really simplify this anymore. And of course there are situations where maybe we don't have to go to an extreme where you have a sophisticated algorithm that needs to be done or something like that with a lot of specific cases, right? It can be as simple as that you're dealing with another system which works in a certain way, and you can't really change it, because if you want to change that system, there's like 100 people in line who's going to tell you that, oh no, we depend on that feature, we depend on that feature. This happens to APIs all the time, guys. Like you have some service somewhere over yonder that takes on too much responsibility or something like that, and all of a sudden everybody needs it, and the team doesn't really know how to deal with all the feature requirements or how to split or do architecture or so forth, and all of a sudden you have a super API that has all these really weird flags and switches and things. It's the equivalent of having a function that knows how to do everything, and you have just like 20 parameters to the function saying that if this is on, do that, if that is on, do that, but if they're both on at the same time, do that. That's something that can happen as well. And even if you can write a clean, or in theory could write a clean solution to that issue, you're locked down because there's a base layer of complexity that you can't change. In my example, the base layer was the inherent logic of the problem, and in this scenario it is someone else has provided this to you and you can't change it, because if you do, other people will be impacted. So what I want you to take away from this is that yes, I've come across, and you will as well, complicated solutions where you can't really make a readable, you can't simplify the problem anymore. And so the thing that I try to preach to people is that the thing that you should practice is how to simplify something as much as possible. Imagine it's a little bit like, think about it conceptually, like, you know, in those, everybody loves those, right? How do you simplify this fraction? I still suck at that because I suck at math, but it's the same problem. If you have a fraction and you learn how to simplify it, then you can simplify the fraction, but you may not be able to simplify the whole the whole equation or something like that. So you can make it slightly easier to deal with this problem, but every problem has its own inherent level of complexity, and in some cases all you can really do is to simplify as much as possible, and then put yourself a little bit, like, and this is my tip to you. This is what I did. I've done in that algorithm that I created, and a few cases as well, where think like, you know, comments that we don't use for anything apart from documenting what a function does. In some cases, just try to think about the next person who's going to read this thing that you now understand. If you can make it easier on them to understand how this thing is working, add a line here saying that, yeah, for example, I had to do this and that because we are currently doing this and that. Maybe that changes in the future. Or give them a reference to something weird that you had to do because of reasons. Try to help them out a little bit. Put yourself outside of your own understanding and say, if I looked at this for the first time, what would I need to know in order to change this thing and make that confident changes to this thing so I don't feel like I broke something, or so forth and so forth. That's unit testing first and foremost, and adding some helpful comments if it's necessary, and try to keep things as decoupled as possible. Have a great day.